Hey everybody, this is John. Today I'm going to show you my low primer warning alarm that I built from my Lee Loadmaster. I'm going to show you how it works, the schematics, and how you can build your own. So here's the Lee Loadmaster priming system. If I turn the alarm on right now, this is what I get. The beep comes on and then it goes away. I'll explain that to you later. But if I pull out the assembly, this is what we've got. Now I've got a sensor located right here, and this sensor will tell me if there are any primers in this chute. So if we were to tip this up like this, I get an alarm saying that the primers are, this is empty. But when the primers run down here, the alarm goes away. So the magic is in the circuit that I've got built and this sensor. So what I've done here is I've taken the chute like this, and I drilled a small hole here. I think this is like a 5/64 drill bit. I drilled a small hole through the bottom side, and then I sort of used a larger drill bit here to make a bit of a hole here. That's so the sensor could rest up against this little pocket. And I also took the same drill bit and I made this side, this hole, bigger also, so the sensor could go in here. Now all this is a emitter detector LED pair that I got from Radio Shack, and what I use is just two nuts on each side, and the LED goes into the hole of the nut, and the nut then is it's all held together with a couple zip ties, and then the wires go from the sensors up into the circuit board. I have all my electronics inside this unit. I use a 12 volt 1200 milliamp adapter to provide the voltage, 12 volts right there. But if I take this apart and take it down, everything is inside here. A bit of a mess, but this is the 12 volt jack, and then I bring the wires off from that, and then that feeds into everything. So if I pull out the board, this is the circuit board that I use for the sensor. What we have is the buzzer, capacitor, some transistors, voltage regulator, and I put it all on this board. It's a perf board and some standoffs, and basically the bottom side are just, it's a whole bunch of holes with copper around some of the holes. And then what you can do is, when you take your components and you bring the leads through the bottom, you just connect the leads together by hand using a pair of tweezers or something, and then you just take your soldering iron and you connect the leads together with a dab of solder. So you want to lay out everything on the top, and it would look something like that, and you just build it. Then your sensor comes in here, and your sensor plugs into here. Well, actually two sensors, two LEDs. They come in here, and they that goes to the sensor, and then you've got your power and ground that comes in here, and that's pretty much it. It's actually a pretty simple circuit, so it's a good one for anyone that wants to get started in trying to build their own electronics. So when I design and prototype a circuit, I first use an experimental board like this. You can get these, I don't know, they're like, each square is like 10 bucks each or something. I got 4 here mounted on this piece of wood. And what you do here is you can bring your power and ground in, like I bring power in on this bus right here, and then I bring ground in on this bus here, and this bus runs along the whole board. And then you can just stab in your components where you want. You can wire them all together with these little wires, and then that will let you see if stuff works. And you can actually bring this down into the garage and hook it up to your machine and actually run buzzers and motors or whatever directly from this board. And then when you see that all your components are correct and the thing is working, then you can just take this and directly bring it to a circuit board, like a perf board, for example. Now there's a couple different perf boards. This is one type. It's just like a little piece of fiberglass with a bunch of holes in it. There's no copper. So this is one type. I don't typically like to use something like this. I like to use this instead. It's the same thing, except one side has copper surrounding each hole. The holes are called vias. So what you would do is you put your components, insert them through this side, like that, and then when you flip them over, they're going to stick out through the bottom. and then you put, like for example, you feed them through and you put a dab of solder on this hole, dab of solder on this hole, then this lead that's hanging out, then you would bring this over with a pair of tweezers or something and wrap it around or bring it next to the hole to its neighbor where you want to connect it to the next guy, because the next guy's lead is sticking through, and then that next guy's lead is also soldered to the hole, and then you can bend over the wires and then you would solder them all together and you'd make everything connect. Okay, so the part that I'm using is Radio Shack infrared emitter detector pair 276142. There's instructions on the back here that basically it's like one is an LED and one is basically a transistor, but the base, instead of being excited by a voltage or a current, it gets excited from the light from this guy. They are polarized, anodes and cathodes, or plus and minus and stuff like that. I don't want to get into too much detail explaining how this works, but to show you physically what it is, you've got one dark one and one light one. The dark one is the emitter, so this is where the light comes from. Now it's infrared, so you're not going to see it glow, so don't expect to see this thing light up when you power it up because it's invisible. But if you were to look at this guy, you would see that one side of it is flat, so that helps signify which side is plus or minus. And again, this is the emitter, and then you have the detector, and this other guy also has one side on it that's flat, and you use that to signify its polarity. Now when you mount these two together, they typically are pretty sensitive. You need to have them really like nose to nose like this. They're not going to work if they're mounted like this or at an angle, so you need to have them like this, and the further apart that you space them, the typically more current you need to put through this guy to make it stronger so this guy can sense it. But when you're going to mount them, like on our device for example, they're pretty close together and they're mounted directly opposite each other in this fashion. They're going through the two nuts. This is the schematic, and what you see here is the two LED detector pair, and from looking down at the top you would see that this guy has a flat side like that. So the flat side is up for this guy, and then you have 5.1 kilo ohm resistor or 5,100 ohm resistor here, and the LED, this guy here, this flat side would be down. You've got 510 ohm resistor here, and you've got another 51,000 ohm, 51k ohm resistor right here. Then we've got some PNP transistors, 2N3906. And then from those guys, the collectors of those guys come out. You've got this 10 kilo ohm resistor going to the base of this guy, and this is an NPN 3904, 2N3904. And then you've got some buzzer, and I'll show you the details of the buzzer in a second. This is basically it. We use a capacitor here. The reason why when you flick on the thing, and even though there's primers in the tube, it still buzzes for a second and slowly decays. That's because this guy here is present. What this capacitor here does is if a primer slides past here really quick and this guy sort of blinks, well, what that would do is that would cause the voltage to blink here, and that would cause this guy to here to turn on and off real quick, and that would cause you to have a quick pulsing buzzer like beep, whatever. So I wanted to get rid of that, so putting this capacitor in here, this capacitor charges up, and what that does is that adds delay to the sensing system such that you don't get you know, a very quick impulse when you get a change of primer passing through the sensor. The capacitor smooths that out. When this thing is powered up, then you typically get like around 20 milliamps coming through this guy. That's going to set the intensity of this guy and how strong it is to drive this guy. And then when this guy turns on, you get around 1.5 milliamps here. And then what happens is when this guy gets excited and turned on, it pulls this voltage down, because this is normally 12 volts. It pulls this voltage down to like 4.5 volts. And then what that guy is, that turns this guy on, which also turns this guy on. So these turn on. When they turn on, it acts sort of like a switch. So it connects this wire essentially to here through these guys that, you know, act like a switch and connect this. And when this goes up, it allows the voltage, like almost 12 volts here, to go through this guy and excite this guy and turn this guy on, and this guy acts like a switch. So that pulls the collector or the output of this guy down almost 0 volts, and then puts a full 12 volts across your buzzer. Now, when the beam is broken, this guy will turn off, so this voltage will go back to around 12 volts, turns this guy and this guy off, which means this guy here will fall probably very low voltage, probably 0.1 volts, maybe all the way to 0 volts. Turns this guy off, and that will turn the buzzer off. Now to implement this, of course you've got these PNP transistors, right, or NPN transistors, and what do they look like? Well, I showed you, they look sort of like this, right? They've got a flat side. Looking at them from the top, they would go in like this, and they've got a collector, base, and emitter as the legs, and I'll show that to you now in a second. You could put them in the circuit just like this, because the emitter, if you were to look at the circuit, the side with the arrow, whether the arrow is pointing in or out, that base, that determines whether it's a PNP or an NPN. So this is a PNP. This is your emitter, this is your base, this is your collector. So that's for this guy here. Likewise, this guy down here, it's emitter, this is an NPN, it's emitter, and this it's base, and then it's collector. It's like that. So this EBC, if you were to look at the device, this is what how the device would go plugged into the board with the CEB wired in just like this. So just follow this and use that and wire up your circuit. So everybody thinks pretty straightforward here when it comes to, if you're looking at the orientation of devices. Resistors, of course, are not polarized. Resistors look something like this. They have bands, color bands that identify what their values are, whether it's a 5K or something like that. They can go in any direction. Capacitors, they are also polarized. Well, the electrolytic capacitors are, and that's what this guy is. Sometimes they're black, sometimes they're blue. There's typically a stripe going down the side with like zeros in it or minus signs in it or something like that. That indicates that's the side that's curved. So this is your minus side on your capacitor, this is your plus side on the capacitor. So again, the stripe here, the color stripe, that's your minus side, and the other side there's no stripe, that's your plus side. So that guy would go plugged in like that. So how do we get 12.3 volts? Well, I use a voltage regulator. So what this guy is, think of like cruise control in your car. You set it to say 70 miles an hour, and if you're going up a hill, which means there's more load on the engine, the cruise control will increase the gas pedal to give you more power to keep you at 70 miles an hour. Or going down a hill, it'll back off on the gas, stuff like that. Voltage regulator does the exact same thing with voltage. So I use a jack, and even though the adapter on my adapter that I use is 12 volts, 1200 milliamps, that rating means you're going to get 12 volts if the thing is drawing 1200 milliamps. Now I'm drawing like maybe 50 milliamps, something very small. So the voltage of the adapter is actually going to be a lot higher. Now if I put different loads on that adapter, say I've got a case feeder going, bullet feeder going, alarm going, and stuff like that, that's going to cause that voltage of the adapter to change. Now I want to always have a good fixed voltage applied to my buzzer or my case feeder or whatever. So I like to use a regulator which will step down the voltage from 16 volts or whatever down to a constant regulated 12.3 volts no matter what. So I use a LM317 voltage regulator. It looks like this, written right on the front. You can probably get this at Radio Shack or eBay or something like that. And I have a jack, 16 volts from the 12 volt adapter. That comes in. Then I use a switch, just a flick switch to turn the thing on. Then I have some capacitors here. What the capacitors do is a 1 microfarad and a 0.1 microfarad. One will filter the lower frequencies. One is a bit better at filtering the higher frequencies. So your power supply is going to be rippling out of your adapter, even though it's DC voltage. It's still going to be fluctuating because how that's created from the wall power, AC power in the wall. So I put a couple capacitors in here. It's not critical you use these valve capacitors as long as you use something. Then you've got this guy here. Now if you were to look at it like this, I'll show you in a second the pinout for this guy. But you bring your 16 volts on the VN pin, and then you put these resistors here. So the way this guy here, this LM317, is actually programmable. A lot of voltage regulators, you either buy them directly off the shelf, you plug them in, you put in some voltage, 12 volts, whatever, and then coming out will be a fixed voltage no matter what. You don't have to use any resistors or anything. So if you want a different value out of your voltage regulator, you're going to have to buy a different voltage regulator. The LM317, however, you can set it to be set to whatever you want. Much like the cruise control in your car, you can set it to whatever speed you want. How you set this guy is using a bunch of different resistors on the outside. So what I use here is a 1 kilo ohm between these two pins, and then down here I use 8.2 kilo ohms and 270 ohms. So that's 8,200 ohms plus 270 ohms. So whatever value of resistor you get here by adding that up, that's what we use down here. And then when you put 16 or 15, all the way, say maybe even as low as 13 volts into this guy here, what you're always going to get out of this guy is going to be around 12.3 volts. So I know no matter what, I've always got a constant, good solid 12.3 volts powering my circuit. Another thing I'd like to note is this buzzer. Depending on the type of buzzer that it is, this one here doesn't draw very much current, and as a result it's a piezoelectric, I think, device or something like that. It's polarized as well. So if you hook it up, best off take a battery, like a 9-volt battery or something, and use it, put the leads, the voltage across the buzzer leads, and it'll beep in one direction, but if you swap the leads around, it probably won't beep in the other direction. So that's a good way to determine which direction the pins have to go in. Obviously the positive pin the positive battery terminal that would make this beep, the positive terminal would have to be here, and then the negative terminal would have to be here. So you may need to determine that ahead of time before you plug this into your circuit to know what polarity the buzzer has to go in when you insert it in this thing. The other thing I recommend is you get yourself a voltmeter. You can get something like this at an auto parts store, or you can even get like this one at Harbor Freight. This one's like, I don't know, $5 or something like that. Even has like this NPN PNP Transistor socket on it. You can stick the transistor in there, emitter base collector, and it'll tell you what the gain is, if the thing is dead or alive, if you think you've blown something up. You can get your components. You can get them at Radio Shack, a little expensive. What I recommend is if you want to get like more resistors so you can plug and play and stuff, go on eBay. You can get yourself like a resistor kit, like 1,000 components for like 10 or 15 bucks or something like that. So eBay is a good place to get these components. You can get a lot more for less, and you know, that way if you blow something up or you want to experiment with other things, you've got all the components right there in front of you. As far as experimenting is concerned, I think that the project board, you put on, you know, you can put on a big piece of board project and you can put the power and ground, plug stuff in. It's a good way to trial and error, find what works for you. But if you don't want to get that involved, you could just take the perf board like I showed you, stick your components in, just make sure that everything is lined up, and don't forget to connect anything. You know, watch the polarity on the components for the you know, the buzzer, the capacitor, and the diodes and the transistors. Also, it's good too when you lay out your board, come in and sort of make like put a line of power right across the top. So run a bare wire along the whole top, put power on the top, put ground on the bottom, bring your plus and minus voltages on this guy and put it there. So then you got power and ground. So then everything, all your components can run just like the picture, right? Just like in the picture, sealing the floor. Your power and ground can run sealing the floor along this guy, and basically you put your components in just like the picture. And you know, when you're done, make sure all the connections are good. If your leads aren't long enough to connect two things together, just take like a short piece of wire, small gauge wire, and you know, just loop from one spot to the next, run it through the hole. So you're going to probably want some like 22 gauge wire, something like that, also to help you make those jumpers and things like that. And you're going to need some wire, of course, to come in from your power adapter jack into your voltage regulator if you choose to use one. You probably don't really need the voltage regulator, but I do recommend it. But you could try without it, of course, and if you feel it run off the adapter, it's fine, well then go for it. You also want to use a switch or something like I have on the face of my unit, where you can flick the thing on and off if you want. So that's pretty much it. Just take your time, make sure you connect everything up, you don't forget anything, and good luck. And you can let me know if you have any questions or comment, let me know how it worked out for you.